Hi, everyone. Let's now talk about issues of modality, basically humps. So all but one of the distributions so far have been unimodal, meaning that they only had one mode or hump, hence unimodal. Let's quickly review. So this over here, this nice bell shape, one hump, one mode, unimodal. Likewise here, for this approximately symmetric bell shape, unimodal. Example 3 is the one exception, where we had a perfectly flat distribution. For a flat uniform distribution, this has no mode. Now, even skewed distributions can have modes. This is unimodal. This is unimodal. Here, the concept of unimodal is a bit fluid. Unimodal, right skewed. Again, unimodal. Now, as I said, the whole concept of modality involving humps, that is a bit fluid. Later on, we're going to have a different definition of a mode for raw data, for lists of values. That's a bit more precise. Right now, we're just thinking humps in the shapes. Now over here, we have a bimodal distribution where we have a couple of humps. Looks like we have one over here and one over here, roughly speaking. Again, it's a bit fluid. But we can call this a bimodal distribution. We have a hump on the left, a hump on the right. Now, if this is a distribution of test scores, what could explain the bimodality? And sometimes as a TA in a calculus class at UCSD, I might see these kinds of bimodal distributions. How do you think these kinds of bimodal distributions might arise in a calculus test, for example? Well, basically students who basically knew their stuff and students who had to pray to the god of partial credit. People who are basically accumulating partial credit but may not have aced any particular problem. So the students who studied versus the students who were riding on partial credit. Sometimes I did see bimodal distributions. A multimodal distribution has more than two modes. So something like this. Okay. Here you might be thinking of a camel. Here you have 3 or 4 humps. That's multimodal. All right, so let's talk about describing distributions that we've seen. So let's talk about these 5 shapes that we've seen. How could you describe them? I'll give you 20 seconds to review these. How would you describe them in terms of symmetry, skewness, and modality? All right, so let's talk about A. How would you describe A? A is a perfectly uniform distribution, which means it's symmetric and it has no mode. Saying it's uniform implies the others. That's symmetric and it has no mode. What about B? That's like for the president's ages. Well, it's unimodal and it's approximately bell-shaped and therefore approximately symmetric. What about C? That's like test scores for quiz 1. It's unimodal and left skewed. Remember, the skewness follows the tail. It's left skewed. What about D? Test scores in a physics class. Again, it's unimodal, but this time it's right skewed. The tail extends to the right. How about E? Bimodal and neither symmetric nor skewed. Although in principle, you could have a bimodal symmetric distribution. You could have something like this, for example. That's bimodal and symmetric. But here, this is bimodal and asymmetric. While we're at it, why don't we go to shodor.org and look at this real-world data. I'll blow this up. A college's SAT math scores. What do you think? I would say unimodal, skew to the right. You have some students who did very well relative to the others. NBA team payrolls. Maybe unimodal over here, skew to the right. You have some people being paid very well over here. Horsepower of cars. Could be unimodal, possibly bimodal, skew to the right perhaps. Cars that do quite well over here on the right, very powerful. Body fat of men. I would say unimodal, pretty symmetric. A little bit of skewness here, but pretty symmetric. You see, real world data is not perfectly categorized. Spending per student in some schools. Looks unimodal, looks, what do you think, skew to the right. Gas mileage for year 2000 cars. Maybe unimodal, skew to the right. Some cars are very efficient. All right. That's lesson 6. Shapes of histograms and distributions. Next up, we're going to talk numbers next time.